Hey everyone, Professor Baldwin here, and today we have another word problem. We're told that the length of a digital photograph is 10 pixels longer than it is wide and has a total area of 2,000 pixels. And we're asked to find the dimensions of this rectangular photograph. So let's draw a picture. We have a rectangular photograph, and it has a length and it has a width. And we know that the area, or the whole shaded image, the area, equals 2,000 pixels. We also know that the formula for area is equal to length times width. And what else do we know about the length or the width? We know that the length is 10 pixels longer than the width. So the length equals the width plus 10. It's 10 longer than the width. Substituting our length, our width, and our area into our area formula, we know 2,000, our area, has to equal our length, which is width plus 10, times the width. Now, in order to be able to solve or find the dimensions, we need to first expand this and then turn it into a polynomial in standard form. So on the right-hand side, we need to distribute this w through that binomial. And we get w squared plus 10w. Now we want to subtract the 2,000 from both sides. That gives us 0 equals w squared plus 10w minus 2,000. Or, because both sides are equal, we can write it as w squared plus 10w minus 2,000 equals 0. Now we need to factor this so that we can solve for w. Our leading coefficient is 1, so we're going to find the values that this factors to fill in our binomials. So we need two numbers that multiply to negative 2,000 but add to 10. 2,000 is kind of big, so think about just the number 20. What numbers multiply to 20? 4 and 5. So what about using 40 and 50? 40 times 50 is 2,000. And if 50 is positive and the 40 is negative, they would multiply to a negative 2,000 and also add to a positive 10. So that means our binomials are w minus 40 and w plus 50. Now that we factored it, we need to use the zero product property to solve. So w minus 40 equals 0, or w plus 50 equals 0. The first one, we add 40 to both sides, and that tells us that the width equals 40. That makes sense. And then the second one, we need to subtract 50 from both sides. This says that w equals negative 50, or that the width of our picture is negative 50 pixels. That's not possible. So we need to throw that out because it doesn't make sense in the context of our problem. So we know that our width is 40. So if w equals 40 pixels, what's our length? Well, we know that the length was equal to the width plus 10. So that has to be 40 plus 10, or 50 pixels.